We've just filled this galvanised bucket about a third full of water. We're now going to add quicklime, which is burnt limestone, into the water. The result will be quite a violent reaction, and we'll end up with lime putty, which is the basic constituent of our plaster. For this job you really do need to be thoroughly protected. The quicklime is highly caustic. It used to be used in the 17th century for dissolving the bodies of condemned criminals, and it'll do the same for you. The calcium oxide is combined with the water to produce calcium hydroxide, which is our lime putty. Generally, the longer you leave the lime putty to stand, the better, and if it's left to stand with a little bit of surplus lime water on the top, it gets more and more elastic with time. The Romans used to store lime putty for 2 or 3 years before they used it for decorative work. And here we have our tub of lime putty, which we'll leave for a month before mixing to use for plaster. The basic chemical principle of lime plaster involves getting limestone, often in the form of chalk. This is calcium carbonate. You heat this up in a kiln to about 1000 degrees, and it drives off the carbon dioxide in the limestone and leaves you with calcium oxide, or quicklime. When you add water to the quicklime to slake it, there's a violent chemical reaction. It becomes calcium hydroxide, which is our lime putty. Mixed with aggregate and applied to the wall as a plaster, it sets by reabsorbing carbon dioxide from the atmosphere and thus turns back into the limestone, the calcium carbonate. But at that stage it's on the wall as plaster. And that's the lime cycle.